Every time you ask ChatGPT a question, well, there's this massive hidden system going to work right behind the scenes. Today, we're going to uncover exactly how these systems actually know what they know in this quick explainer. Let's dive in. So, one of the absolute most important architectures powering modern AI today is called RAG. That stands for Retrieval Augmented Generation. I know, it sounds super technical, right? But honestly, it's the secret sauce that makes AI actually useful and accurate in the real world.
But what actually happens inside it? Let's just break it all down, step by step.
It all starts with data sources, and the variety here is huge. We're talking PDFs, websites, text documents, massive databases, or even internal company files and entire knowledge bases. But here's the catch. You can't just dump all of that raw data directly into an AI model. It doesn't work like that. Instead, the system first splits all that information into smaller, bite-sized pieces. In the industry, we call these pieces chunks. Think of it kind of like this. Imagine trying to find one specific fact hidden in a massive 1,000-page book. It would take forever, right? But if you break that huge book down into smaller, highly searchable paragraphs, well, it becomes incredibly efficient to find exactly what you need. That is chunking. Next comes a pretty fascinating step. An embedding model steps in and actually converts each of those text chunks into numerical vectors. Now, these aren't just random numbers. They're mathematical representations that perfectly capture the deep meaning and context of the text. Once we have these chunk vectors, they need a home, so they get permanently stored inside a vector database. You can basically picture this as a giant, high-speed library organized entirely by mathematical meaning. Now, imagine a user actually asks a question. That query goes on its own parallel journey. It gets passed through that exact same embedding model we just talked about, and it's converted into its own mathematical vector, a query vector. So now, the stored data and the user's question are literally speaking the exact same mathematical language. And this is where the real magic of RAG happens. The vector database performs what's called a similarity search. Instead of doing an old-school search where it just looks for exact keyword matches, it's actually searching for meaning. It rapidly compares the query vector against all those stored chunk vectors and finds the chunks that are semantically closest to the user's question. Those highly relevant, retrieved chunks are then pulled forward during prompt assembly. This creates what we call an augmented prompt. So now, the large language model receives three things all at once: the original question, the newly retrieved context, and the instructions. It's fully propped with everything it needs. So why does this matter so much? Because this dramatically improves accuracy. The AI is no longer relying purely on its static training memory. It now has access to highly relevant, real-time external knowledge directly injected right into its prompt. Finally, the LLM generates what's known as a grounded response. This is a response firmly rooted in actual retrieved facts, rather than the AI just guessing or hallucinating. It gives you an answer that is precise, reliable, and totally verifiable. And that precise reliability is exactly why RAG has become such a foundational architecture in modern AI systems. From enterprise chatbots securely handling company data, to AI search engines pulling real-time web results, to your favorite coding assistants, RAG is literally everywhere. The next time you interact with an AI and just marvel at its specific knowledge, remember the hidden engine making it all possible. Retrieval Augmented Generation is completely reshaping how we interact with information. And frankly, this is only the beginning.